In this video, we'll use the software SigmaWin Ver.7 to work with Sigma-7 alarms and monitors on the demo system. Hi, I'm Matt Pelletier. Here's a quick preview. First, we'll use the controller to simulate an alarm condition on the Z-axis. Then we'll use Sigma-7's built-in alarm diagnosis tools to investigate the cause of the alarm and to clear it. We'll also explore the alarm trace function to see a graph of what happens moments before and moments after the alarm takes place. We'll try out some monitors that give live feedback data of the servo's operation, and show how to use software reset to clear alarms that require power cycle. All right, let's do it. So I've got remote connection to the demo system here. And I think the easiest way for this controller to give a command that produces an alarm in the servo is to set the speed too high. Let's turn the servo on, and then set the speed to 4,500. Now if I jog at that speed, you see the motor took off, and I've got now alarm AD00. That's even displayed for me on the HMI. But what does this code mean, AD00? For that, we'll have to go to SigmaWin Ver.7 and go into this menu. And about halfway down on the left, you see Alarm, Display Alarm. Now this code is listed again with a little bit more information. I'll just widen that column a little bit. And the error is Position Deviation Overflow. So I guess that means it wasn't really the speed that was too high, but rather the position error during the move that was too high. If you look down below, this alarm has several causes, investigative actions, and corrective actions. And as it says here, one possibility is that there's incorrect wiring to the motor. But this isn't the only possibility. There's other causes here that you can page through. Let's see what we've got. The servo pack gain could be too low. The position reference pulse frequency is too high. That kind of describes what just happened. Cause number 4. The acceleration is too fast. Maybe that's part of it. And number 5, there's even a parameter to set the alarm error level. Maybe that parameter is too low. And finally, number 6, it could be that it's just a servo pack fault. In fact, all of this troubleshooting information really comes from the product manual. Looking in the maintenance section under Troubleshooting Alarms, we can scroll down to the alarm AD00 to see the same information for troubleshooting this alarm. Back to the software, if you look at the very bottom of this panel, you see a monitor at occurrence of alarm. And this can really help in the troubleshooting process because there's a snapshot of critical system information at the time of the alarm. The speed feedback, the reference, the torque, the position error, even the DC bus voltage level, and the RMS torque here called accumulated load ratio and the regen power. And do note at the bottom that these causes are only suggestions. The true cause of the alarm might be something else. Let's go back up to the top here now and just reset this alarm with the button Reset Axes. And that clears out the alarm. If you get any alarms in the future, you can come in here to the alarm display and reset them. They can also be reset through the controller using the remote I/O interface and this alarm reset button. To further aid in troubleshooting, sometimes it's helpful to see what alarms happened in the past. So select Alarm History, and you'll see a list of up to 10 alarms in order of most recent occurrence. In this list, you'll see that some, not necessarily all, of the alarms have a trace available. You can select one of these alarms from the history, and then click here on View Trace Waveform. You do have to be patient, as it can take a little while to load the trace over this remote connection. This alarm trace shows what happened to the motor torque, feedback speed, and commanded reference speed in the last 800 milliseconds before the alarm. Here's the alarm signal, and you can see this is the point in time here where the T is pointing to triggered on the alarm going from low to high. It also shows about 200 milliseconds after that point in time where the alarm happened. So what do we see on this trace? The torque went up to about 100%. The reference speed increased to about 750 RPM. And so if you look at the data tab, you can hide these signals to clean it up a little bit. For example, data 3 reference speed, you could hide that. However, there are other signals not shown by default that are recorded by the alarm trace. For example, you could change data 1 to position reference speed. And then click auto to auto scale it. This is the command to the servo from the controller. Likewise, under data 2, you could change that to position error. Be sure it's not hidden, but displayed, and then auto scale that one. And then how about we use this magnifying glass, and then you can draw to select an area for zoom. Now it's a little bit easier to see that the position error was high for some time during the move command. There's also a button to the left of the magnifying glass for cursors. And with these cursors, you can measure a little bit more exactly, either vertical for time or horizontal for amplitude. Let's close that out. You could save this trace data as a CSV file, look at it in Excel. Let's cancel that. You could also capture a screenshot with different capture options here. Cancel that for now. And also you can save it in the native format to pull it up later. We'll cancel that too. And we'll be doing a lot more with the trace feature in the tuning portion of this training series. Okay, let's close out the alarm trace, and we won't save it. And when your troubleshooting process is successful, you can clear out these old alarm history items with the clear button and click yes. And this will give you a fresh history for this particular amplifier. When troubleshooting Yaskawa servos and looking at these codes, it's important to understand the difference between these terms, alarm and warning. This distinction can be seen in the maintenance section of the manual, with this division between alarm displays and warning displays. We use the term alarm to mean that motion cannot continue, and so the servo automatically turns off. If the motor was moving, it will stop according to the alarm stop mode setting, and the alarm code will appear on the front of the panel like we saw with the letter A and then 3 digits after that. That's the alarm code. A few examples are, as we saw, AD00, position error, overload, undervoltage, and overspeed. A warning, however, is a prediction of a future alarm given the current conditions. If there's a warning, the servo stays on and motion will continue, but a warning code is displayed also beginning with A, but followed always by 9 and then 2 more digits. This way the controller can be programmed to detect the warning and respond accordingly in order to avoid the alarm and the downtime associated with recovering from that alarm. Since you can't predict every alarm, there's a lot fewer warnings than alarms. And there are some conditions, such as Mechatrolink command warnings, that will never result in alarms. Alarms and warnings can generally be cleared with the alarm reset command, as we've done, although some alarms do require power cycle to clear, and some warnings do clear themselves automatically. Now, let's look at the monitoring capability of SigmaWin Plus with Sigma-7, and go with me here to the menu of the X and Y axis, and focus on this section here, Read Product Information. This isn't too exciting, but it can be very important to see the motor model that's connected. You may not be able to read the nameplate due to the location or installation of the product. You also have access to the serial number, date of manufacture, and it can be useful also to know the resolution of the encoder, 16,777,216 pulses per revolution. Another thing that's nice is you can go now to the Z-axis, the SGD7S, and also pull up the product information, and that appears below. And so if you expand, you can see all of the servos here simultaneously. All right, so we can confirm what's connected. Let's close that out. And let's do the same thing now with the next section, which was under Monitor. Choose Monitor. And here you see operation-related monitors at the top. And then status, on-off type of monitors at the bottom. There's both status and I/O. Down at the bottom, there are different filters, and one of them is to filter out this control column. The control column just tells you whether this monitor applies to position, speed, or torque control mode. If you know what control mode you're in, then you can ignore the monitors that don't pertain to that mode, or you can hide it altogether just to free up some more space. I think I'll show the control modes. Another option we have for filtering is the standard filter, which is what you'll probably have by default. I've cleared the filter. Let me go back to standard here. And this standard filter just shows the most common monitors, such as speed and position error and that load ratio that we talked about. Down here, the same thing for status and I/O. Just makes the list a little bit shorter for you. But if you'd like to see every possible operation monitor and every possible status and I/O monitor, you can clear this and confirm. Let's watch some of these monitors now in action. If you pull up your remote I/O, and this time let's turn on the x-axis. That'll be axis A. And jog. And you see that results in a speed reference and internal torque reference, position error, etc. Okay, let's close the monitor for this servo and open up the monitor for axis Z. And I want to use axis Z so that we can look at the I/O monitor and then pull up the Yaskawa Remote I/O interface. The only inputs that we have connected to the servo are an axis Z, the pot and not inputs to the servo. To turn this disconnected, goes from low to high, back to low, disconnected here from low to high. And this leads me into another way to look at the inputs and outputs, and it's called I/O signal allocation. Let's close the I/O monitor, and from the Z-axis menu, go to I/O signal allocation. You can see there's a tab for input signals and output signals. Let's look at input signals first and pull up the remote I/O. You can see I can disconnect the POT input and the status goes from low to high, or connect it, it goes from high to low. Same thing for the negative over travel, NOT. Low and high refers not to the logical state, but to the voltage you would expect using a multimeter on the terminals themselves. When the electrical connection is made, there will be 0 volts across the terminal. And likewise, when it's open, you'll have the power supply voltage, 24 volts. The same is true for the outputs, and there's even a good way here to test your outputs, whether you have relays or LEDs or some kind of indicator connected to them. You can go to forced output mode, and in a forced output mode, we can force low and force high each of the different outputs. Now, in this case, with the remote demo, we don't have anything wired to the outputs of the servos themselves, so we will not be able to confirm this with the demo. All right, let's leave I/O signal allocation. It's prompting us to leave forced output mode and go back to normal, so okay. But I want to show you what happens after this function, or really any function that takes over control of the servo. When you try to go back to control of the servo on that axis with the controller, like we can do here, particularly turning the servo on, you will immediately get this alarm A.B0. So as we did earlier, we can troubleshoot this alarm. Go to display alarm for this axis. And you see this alarm is called invalid servo on command. After executing the utility function, to turn on the power to the motor, the servo on command was sent from the host controller. That's what we did. We tried to send the command from the host controller. And what is the corrective action? You can't just reset this one. You're going to need to restart the system. So what does it mean, restart the system? Let's close this alarm display and go to software reset. Software reset will cause the servo to reboot, just that one servo. So let's click execute, and then I'll pull up the video here. You see the drive just turned off for a couple seconds, and now it's back online and that alarm is cleared. So I wanted you to see how software reset is important for recovering from alarms that cannot be cleared, such as A.0B0. and others that we'll encounter later, such as A.810. Finally, now under monitors, let's open Life Monitor. Let's click on that one. There are two sections of Life Monitor, the Installation Environment Monitor and Life Prediction Monitor. These are new for Sigma-7. So what are these about? The Installation Environment Monitor is about temperature, where 100% is 85 degrees Celsius. So the servo amplifier and motor right now are in the good range, 50 or so percent of the way to 85C. It's also worth mentioning that there are monitor numbers, 25A and 25B, which it can be used by the controller if you want to pull this into the controller program and do any monitoring of the temperature in the controller program itself. The bottom half of this Life Monitor is the Life Prediction Monitor of the capacitor, surge prevention circuit, and dynamic brake circuit. And here's some of the specs for some of these components for particularly the capacitor here of 10 years. And so this is explaining the expected capacitor life that is remaining right now. And as time goes on, of course, these levels will come down. And when the level gets down to less than or equal to 10%, then you'll have a warning. Remember, warning means the servo stays on. There will be warning A9B0. This is the amplifier basically warning you that it's time to send in the device for service, and hopefully you can reduce downtime with a little preventive maintenance. Of course, there's parameters and options for everything. You can disable this warning feature. For more information on Sigma-7, please go to Yaskawa.com. And with that, we can close these monitors. Sigma-7 servo products.